Welcome back to More Fun Fixing It. It's another Fix It Wednesday. Maybe I could have done these on a Friday. Anyway, I've got this ZX Spectrum here and amongst the mess on my desk. And this was the other one from the last ZX Spectrum video that I put out where I mentioned this one in the intro to that and then didn't get to it because the other one got a bit more interesting. But this one is missing its minus 5 volts. And in that video, I looked at the schematic for the issue 3B, and this, sorry, let's actually have a look at this board first, because there's something on this board that's a bit interesting, and that is that all of the lower RAM except for one chip is socketed. The CPU is socketed, the ROM is socketed, and all of the upper memory is socketed, but none of the logic chips associated with the lower RAM, those two there, or these four here that are associated with the upper RAM, are socketed. If this was originally a 16K machine, then you would expect that all of the upper RAM would be socketed, and IC 25, 24, 23 and 24 would be socketed as well. That's just how they came from the factory, and then they installed the chips after if they were upgraded. But they're not, so this has been changed. And if you look on the back of the board, all of the upper RAM and all of the lower RAM, apart from that one chip, are socketed, have been worked and changed. The CPU has been changed and the ROM has been changed. This has had a life, and this it looks like period correct solder. So the flux is crystallized and dried out, and I'd expect that's been on there for some years. So let's do the normal tests that we would do with a multimeter before we go any further. So I've got the multimeter on resistance mode. Let's pop it there, and I'm going to put one probe on the on the screw for the voltage regulator, and one on the input side, and that's fine. As long as it's not dead short and not too low, that's fine as well on the output side. And then if I move over to the lower RAM, and then we measure the voltage rails, which are pins 1, 8 and 9, and again, as long as none of those are shorted or too low, then they're all good. That's good. The next thing to check, I usually check the diodes next, but I know that one of these is faulty. So let's go straight to the coil, and the coil is, what's going on here? Oh, the coil is actually okay. Well, there's some resistance there that shouldn't be there. That should be shorted this way, and it is. And that's straight through the windings, and this is from one winding to another. So that's oh, actually no, the TR4 and TR5 are okay on this one as far as I can tell. If I go to diode mode, the black lead in the middle of TR4, red lead on the outside, nothing and nothing, and then red in the middle, I should get 0.66 and 0.66 on both sides. Black lead in the middle of TR5 and 0.7 on that side. It should be 1.7 or 0.7 on that side. Okay, that's not quite right. And nothing on that side, and 1 point something on that side. That is normal. So they appear normal. Now, normally at this point, I would plug this in with my Steam Card Pro, which is with my Steam Card Pro, or a similar diagnostic device that shows the voltages on an LED, if they're present or not. But I'm not going to do that this time because I've already done that. I did that in the triage episode, I think. I've definitely done it, and -5 was missing. So we've got some components to look at. This part of the circuit is where I'm going to concentrate on, because right, TR4 is here, and that's part of where -5 will appear from. These three components are directly on that line. There's also some other ones here, some diodes and a capacitor there, but there's a capacitor, diode and resistor on this line here that I want to check first, because they're going to be the ones that are the most likely culprits of why this has disappeared. And C46, being the only electrolytic capacitor on this line, is my first target. Well, was my first target when I looked at this before, because I know that there is a problem with it. I've got my ESR meter here, which I do like this tool. This is really good. And I'm going to plug this into C46. Actually, let's go for C46 is a 1 microfarad capacitor. I think is C47 1 microfarad as well? No, that's 22. Oh no, C27, the reset cap, which is always bad on issue 2. Well, not always bad, but it's very often a problem on issue 2s. Let's check that one first. And okay, that one is bad as well. Oh, we can have some really bad capacitors on here. So let's go to C46 then. And this is doing nothing. Well, I've got my multimeter. That's one other tool I've got. I can test capacitance in this. Oh, gone past it. Right, so I can test capacitance in this. Get the light leads the right way around. That's saying around 6 microfarad for C27. And for C46, that's struggling to read that. Now, it is an in-circuit reading, and that's never ideal. But let's just try a brand new 1 microfarad cap out of circuit, just to give us some baseline, and that's just reading 1.1 microfarad. And with the ESR meter, I want to see what the resistance is on this. The equivalent series resistance is 1.56 ohms. Yeah, 1.6-ish ohms. These are 50 volt caps. This doesn't actually, on the chart that it shows you on here, it doesn't actually show you 1 microfarad. It only goes down to 10, which isn't ideal. It doesn't really give me the best idea. But I have got this new tool, which is the same brand as my portable oscilloscope, Zoe. And this was recommended by Tony 359 on his YouTube channel. And Chrissy made me aware of this, Chrissy Vaps. And look at this. 1 microfarad, 4.9 ESR at 1K. And this one I can change the frequency it tests at. So this is at 10K. It's even more accurate, 1.4 ohms. So I'm going to go in the middle at 1K. And what if we test this? What do we get? And now, again, it's in circuit, so it's actually just giving us resistance. If I force this to go to capacitance, it's 220 nanofarad. And this one is, it's difficult to show you this one on camera because of the awkward angles I have to hold it at. 370 nanofarad. I think the thing to do is to lift one end of this and test it like it's out of circuit. In fact, I'm just going to remove it. God, that nearly sucked the capacitor through. Okay, out of circuit, nice and hot. What do we get? 140, 130 picofarad and dropping. And that could even be the... I'm getting 82 off of the desk. Yeah, 93 picofarad and 412k resistance. That might be bad. It's not even registering. Yeah, this cap is shot. I wonder what my old component tester makes of it. Should Be interesting. It still says it's a capacitor, but a 71 picofarad capacitor. Capacitors in ZX Spectrums are a mixed kind of bag. You can get an issue 2 that still works with its original capacitors now. And if you buy a ZX Spectrum and it's an issue 2 or a 3, I would recommend you get it recapped. The capacitors are not going to leak and destroy the motherboard, but if the 5 volts, minus 5 volts or 12 volts disappears as it heads to the lower RAM will destroy itself if it's left on. So I would say if you own a ZX Spectrum, I recommend you get it recapped. It's a safer bet. I know that I don't always recap them, and I've explained why that is, and I'm always going to get comments about it, but that's it's a different case, and if I can demonstrate that the caps are working using diagnostic equipment, I'm not going to change them. If somebody wants me to change them, then they're going to have to pay for it. Not that I do this as a service, I should point that out. But yeah, good tool this. I quite like this. I'm not so keen on the tweezer aspect of it, but it's a bit clumsy, but it does work. So let's, I think what I'm going to have to do with this one is recap the whole board. But let's have a quick look at some of the other caps with this meter. This one seems to work well in circuit, this ESR meter. The other one, this one, not so much. So that's like 5.5 ohms. I would change that. If I, come on. If I measure this one with this, at 1K, it's saying 29 microfarad, but 9.4 ohms. And this one is 65 microfarad at 5 ohms. But these are all in circuit, so the capacitance is going to be all over the place. And that one's 170 microfarad. What I do like about this is it's really nice and quick to move around. 88 on 100 microfarad capacitor. These look okay. 88, but really high resistance. That one is only 1. That one's really good. That's 1.5 ohms ESR, and this one is 693 mega ohms. This one should be a 22, and that's measuring at 33 at 7 ohms, so that's probably okay. That's the one that's bad. This one, very difficult to film this. 4.5 picofarad, no, that's not right. Yeah, that one's gone as well. That one's down in the picofarad range, about this 4.7. 4.35, that's good, that one. But there's enough here that are bad that I think I should change all of them. Right, that's all the caps out. Let's have a quick look. I kept the 100 nanofarads in the same orientation as they were in the board, but I want to see what this makes of them. Sorry, 100 microfarad it's coming out 102 microfarad, but at 520 mega ohm. 100 microfarad, that's 227, so a higher, these are higher, 35 volts, so maybe that's because of that. So what about this one? 75 microfarad. Let's go through these. This is a 22. That's coming out at 33. That one's coming out at 34, 35. This one's another 22. It's not too bad, that one, 26. Probably okay. 15, 17. What is this? This is a 1 microfarad. And that's coming out at 20 nanofarad. Yeah, that's bad. This one is a 22. Boy, yeah, look at this one. This one's all over the place. What's going on? Oh, it's settled down now. 28. Maybe I just didn't have good contact with it. This is a 1 microfarad. Yeah, this is that picofarad one. It's 87 picofarad. And another 22. 42 microfarad. That's very bad. That's double the actual rated capacitance. This one's 22 as well. 36. That's 6 or 7 ohms. And this is a 4.7. Oops. Which is okay. Most of them are okay, but we've got 4 that are bad. Definitely bad. So you get boards like this sometimes where they just need recapping. I haven't recapped every board I've come across because I've found that a lot of the caps have been okay in a lot of the boards. This must have been abused in some way. Make these capacitors go bad, or it's just been in a very hot environment or run very hot. Who knows? We still got, you know, once this is recapped, we still have the adventure of finding out if there's any problems under these sockets and any destruction caused by all of those chips having been changed. Apart from that one, I still don't understand why that one single 4116 DRAM chip has not been changed. Right. The first thing I do before I plug this into capture is just see if the voltages are there with current limiting on. And here we go. Yes. And it's running. Marvelous. So the only question now is what else is wrong with it? Oh, one thing that's wrong with it is it doesn't have a composite mod. So let's do that first. All right, let's try. Hey, that was quite quick. Okay, so looking at that, as I switch that on, the black screen, the amount of time that the black screen is on is how long it takes to do the self-test of memory. And it's looking to me like that's only doing 16K. Yeah, that's just 16K. So when I plug this in, it's going to give us some memory faults in the upper memory. Apologies for the picture quality. I am looking for a replacement capture device. Yeah, upper RAM is failing. 15, 16, 20 and 21. Wow. So these two here and these two here. Oh, the legs are not looking very good on these. They are quite corroded, but we're going to give it a go anyway. All right, so this is the IC out of 15. If you want to know what this device is, this is a Pico DRAM tester, and I featured it on my main channel, so I'll leave a link in the description, or I'll put a card there. Well, it might be there, I don't know. 4164. Yeah, but this one, this tester can't do upper memory for ZX Spectrums. Although what are these? 4532s are half bad from the factory, so this tester can do them. So can the Retro Chip Tester Pro. Oh, that's just bad. Well, that one's bad, according to this tester. I might put these through the Retro Chip Tester Pro as well. That one's bad. 20 is bad. And 21 is bad as well. It's just for curiosity's sake, I'm going to take out some of these good ones and test these in here. Okay. Okay, that's exactly what we should be. The result we're looking for, a half bad chip. So the upper half of the memory space is actually, or the address space is actually okay. Okay, I'm going to leave those in their sockets for now, and we'll replace all of these other ones. I have some legs to straighten out. And these are 4164 chips, and they are not bad in one half. So I get all 4 squares on the tester will come up green, but the Spectrum will just ignore the half that it doesn't use. Right, let's see if that's fixed it. It's a good quality test in the Spectrum Diagnostics. Hey, excellent. Well, having chips socketed really does make a big difference to the amount of time it takes to fix. If these had all been soldered directly to the board, then well, I've been here for half an hour or more pulling one chip at a time and finding out which ones were broken. And but instantly the diagnostics told me that 4 chips were bad, and properly bad as well. Well, they're going in the parts bin. Okay, I'm just checking for dry solder around the voltage regulator and the power jack and the audio jacks. Nothing's looking crusty, so this can go back in its case. I like this case as well. Got microchips, Waterloo Road. This was obviously fixed at some point. Oh, these must be the guys that did the replacement of the sockets, and they did a good job. They did a good job of actually replacing all of these. They've left a lot of flux here, but that wouldn't have been a concern to them in those days, and it hasn't corroded, so they've used flux that's good quality. So they replaced 7 lower RAM, all of the upper RAM, the CPU and the ROM. All were replaced. It's a Zilog CPU from 1986. And the RAM that's left in here, so I've replaced this one, this one, this one and this one, but this one is 82, 84, 82 and 82. So it's a bit of a mixed bag. I think they've probably just put in what they had handy. But it looks like they took all of these out to test and passed them. And back in those days, most repair shops would have just cut the legs and then resoldered them. So I'm very grateful that they took them out, put sockets in, and obviously this one was the one at fault, because this one is odd to all of the rest. This one is from 1986, which is the same year as the CPU. That's nice. But all of these, this one is, oh no, that one's different. So they must have put these in as well. These are all STC, and this is an ITT. That's also an STC, but these are all from 1984. Really strange. Anyway, let's put it back in its case. Put the keyboard in, see if the keyboard works. Maybe play a game. Okay, my main camera battery died, and that's the one that takes the audio. So I've probably lost a fair chunk of footage. I'm hoping it will not be too much, but I'll just quickly recap. I've tested the keyboard. The keyboard is working perfectly. And I switched it on, tested the keyboard, and it all works fine. So I just want to make sure it actually works by playing a game. Obviously. Usual excuses apply. I'm playing through capture. I can barely see it. It's a tiny little screen. I can't see the flashing keys. Oh, I missed that one. I missed that one. Skills. All right, this one's buttoned up and ready to go back now. Recapped plus comp mod 4 bad RAM. Marvellous. I enjoyed that one. That was a nice simple one. Thanks for watching. See you in the next one. I don't know what I'm pressing here.